Awesome. Thank you all for coming out after lunch here. Hopefully be exciting. Thank you all for being the first people in my life to put headphones on because you want to hear what I have to say versus avoiding me, which most of my team does. So I like that. So thank you. My name's Ryan Johnson. I'm the VP of Software Engineering at Arccos Golf. You may not have heard of Arccos Golf, but I'll give you a little bit of a rundown here of what we do. But excited to talk to you all today about some of the things we're doing with generative AI in the golf analytics space to really make golf a more accessible sport and help people improve their game. So let's get going. Before I get going too much, who here would consider themselves a golfer? Oh wow, a good chunk of y'all. That's awesome. I will get more into golf than I would have otherwise here, given this audience. So we'll be a little more golf technical. We'll still be a little technical, but we'll get a little bit more into golf analytics here. I'm excited about that. Part of the reason I asked that question was because while we're talking about golf analytics, I think some of these lessons are more broadly applicable, whether you're in golf or you're in sports or just in business more generally. If you go back and look at like what our job is as data engineers, analysts, is to take the data we have and to drive impact with it, to drive change. For Arccos Golf, that's to help golfers get better at golf. That might be different for your business. It might be to make better business decisions. It might be to improve the product for your customers. But if you just collect all this data, you let it sit on S3, you do all this analysis, no one understands it, it's all for naught, right? So really we should go back to first principles here, and our goal is how do we drive impact and change? And that's where one thing we've been doing for all time, for those of you who don't know about Arccos, we're a golf tracking app. So our customers go and they get sensors for their clubs, they pair them up with their phone, and they go out and play their round of golf. And from that round of golf, we track all the on-course performance, their shots, and a lot of metadata surrounding it. And then we can tell them what they did really well and where they need to improve. And we've been doing this for a while, about 7 to 9 years. We have over 1 billion shots. We have this huge data set, probably the largest in at least amateur golf data. And we've been pretty effective at translating that into successful performance improvements. Our average customer in their first year drops 5 strokes off of your game. Y'all are golfers, you know what that is. That's a pretty substantial improvement if you're a mid or high handicap. If you're a low handicap, it's not 5 strokes, but it's still a pretty large percentage of your game. You get a lot better. So this is what we've been doing, and a lot of what we can do in the future has been really transformative by generative AI. So let's break down what we're going to talk about here. First, I'm going to break down the challenge with analytics generally, but we'll go a little bit more into detail with golf and sports analytics. Talk about the product we built to help our users understand their game better using Amazon Bedrock. Talk about the lessons learned from building that, which hopefully you all will find applicable to your businesses. Go into a little bit more technical detail there. We'll spend a bulk of our time there. And then actually end on something I'm very excited about, which is how we can pull LLMs forward into this cycle of data capture, data analysis, and then data communication to drive impact. I think this is an underappreciated area for LLM usage. So let's start here with the challenge with analytics. So my mom always said, people don't like 4-letter words. In this case, that 4-letter word is math. People don't like math. This is a tweet to Lou Stagner. Lou's our head of data analytics. Some of you might be following him on Twitter or X, whatever you want to call it. You think math is all that matters. Math is often wrong. You don't hit the golf ball with a calculator. I don't think I could sum up people's aversion to math better than this one guy here. While he is true that you do not use a calculator to physically hit a golf ball, math is incredibly useful. And this is like the overall general aversion we all face, whether it's golf analytics, whether it's business analytics. People struggle with analytics and numbers. There's just a general aversion to it. So why is that, and why is it a challenge, particularly in golf analytics, in our domain? And I think it can be properly summed up as people understand one-dimensional analytics. They're easy to comprehend. People don't have a lot of time or a lot of passion to get into the same level of detail an analyst or somebody else would to really fully dig deep, but they get the basic stuff. But the problem there is that basic stuff is of low value. So, in the golf space, some common metrics here are fairways hit, the number of putts, but let's just be honest, those are old, crusty analytics that aren't very good anymore and actually have low probative value. So let's go with number of putts. This is where I was gonna say we'll get a little bit more into golf analytics. Here's what you all get. So number of putts is actually correlated to how your approach in short game is. It's not really probative about your putting statistics. Maybe to a degree it is, but really tells more about how far you put the ball away from the pin in your shorted approach game. But people get it. It's simple to say, I had 35 putts that round, or 40, if you're me, 75 putts that round. Where we need to go with analytics, and where I think we have gone with analytics on the hardcore analysis side, is multidimensional. They're super probative, but they're hard to comprehend. In golf, it's strokes gained. Who here knows what strokes gained is? Okay, 3 of y'all in a crowd that said about almost all of y'all were golfers, which is kind of exactly my point. It's the best way to analyze your golf game. It is also exceedingly complicated and inaccessible. Essentially, I'm going to oversimplify it here. Strokes gained is you can look at a shot-by-shot basis and determine how did you perform against a benchmark, say a tour player or a scratch golfer or whoever you want to do on a shot-by-shot basis. But there's a lot more to it than that, and it's also kind of tough to just comprehend. Plus, 0.2 is actually a really good strokes gained. You gained 0.2 of a stroke on your comparison group. You get +2 as a score in a hole, you just double bogeyed. That's not very good, right? Just the basic scale that strokes gained is on is counterintuitive for the average golfer. I think most people can't actually explain what slope and rating and handicap are, but it's a good way, it's probably the proper way to measure your golf performance. So this is like the fundamental challenge we have in golf, probably sports more broadly, and I would say probably in the business space. So there are ways to solve this that aren't LLMs and generative AI. I know that may shock a lot of you having heard so much about generative AI this week, but there are ways to do this. And it's largely through humans processing that data and communicating it back. And we partnered with Eduardo Molinari, who's this amazing golfer, an amazing human being. He is on the European World Tour, but he's also a trained engineer. And he is the sports analytics guy to most of the top 10 golfers in the world. And it works great. It solves this problem. Eduardo solves it, his team solved this problem, but it's very high touch, it's very costly, great output, but that doesn't scale, right? There is one Eduardo, he can't answer all of our customers' requests. So this is where LLMs are the obvious solution to at least democratize this to some degree. But we don't want to just ship generative AI for generative AI's sake, right? Up here, you'll see some quotes from an app that I absolutely love and respect dearly. They do some really innovative stuff, and we at Arccos are fortunate that they launched a similar concept before we did that we could learn from it. You don't want, quote, generated obvious stuff, it is no help to anyone. You don't want to use generative AI that is remotely incorrect. Very similar to what they did here too. I mentioned this not to shame them or anything, but to highlight the problems that we wanted to address with our core product towards users here as we built this out. You'll see these themes come back out later, and it's actual public feedback for people who were before us in this space. So let's talk about what we did here. This is the Arccos driver report. You all are a bunch of golfers. You know how important driving is off the tee. It's also where you probably spend the most money on clubs. Most often, you might buy a new driver every 1 or 2 years like I do, just to improve my game. It's also the most fun area. Everyone loves to hit a long drive. On a more analytical level, it's a critical piece of your game, right? If you have a bad tee shot, it sets you up to struggle the rest of that hole, right? So if we can get our golfers better at driving by communicating what is going well, we'll make a meaningful impact on them. Again, our goal is to drive impacts of the data. But we have a lot of data on your driver. We have a lot of ways to cut that data. How do we use the LLM to summarize it and focus their attention? So that's at the product level, but I'm an engineer. So let's talk about the stuff we do on an engineering level and kind of some of the constraints we put on ourselves here. We are a startup. We are not a huge company. We want to do this quickly, efficiently, and get it out to our customers as fast as possible. We want to learn from numeric input. What drives good numeric input? Drives good textual output. LLMs are not calculators that you hit golf balls with. They don't think in numbers, they think in tokens. Very different thing. We want to go quick to proof of concept. So we intentionally didn't do things like fine tuning. We want to personalize it. We want to don't repeat stats, and we want to focus the user. Again, go back to that comment you saw from that other app, which will remain nameless, where they just regurgitated a bunch of information. We want to avoid the LLM doing that. So we did that. I'm not going to probably surprise you. It worked well. We got there. Great. End of presentation. No. I want to tell you where we struggled there, so hopefully you all can learn from this too, and as you go through, we'll take some of these lessons to your app as well. So the first thing that was, I think, kind of surprising to us, you might say in hindsight, it's pretty predictable. We actually spent a lot more time on the orchestration layer of our report. You could have probably, in a non-LLM world, built this out in just a one script that runs and everything, puts out a PDF at the end. But if you step back and think about it, the LLM, in order to generate output, requires all the other data that is in that report, right? We didn't do a RAG here intentionally because we want the LLM to see the same thing the user sees and then direct their attention to the right parts of that presentation. So essentially, we had to generate the entire report, sans the text, before we ran our LLM. So we did that using step functions. It worked great for us there to run lambdas and generate those other pieces of data. There are probably 50 different ways to do this technically. This is the one we chose. It worked great. Then we feed all that data into the LLM, generate the text, then put everything back together into the report that goes out. But we spent more time there than I think we intended to early on. So the other thing that was we spent a lot of time on was just model choice and prompt optimization. And that's kind of table stakes of using LLMs and generative AI at this point. But I want to highlight one of the advantages to Bedrock that we got out of this was it allowed us to test out a bunch of different models and find which one was the right for us, and then find the right balance between quality of output and cost of output. Do we need a big model? Do we need a small model? It's usually just one string that goes into the conversation to test them out. So we were able initially to test out different models and then have humans read the text and say this looks good or this looks bad. That again, not scalable. LLMs are helpful here. We then got to a point where we started feeding different model outputs into a model and then having it say this is a score of from 0 to 100 to kind of help do that at scale to pick the right model. We ended up using the latest Claude version. When they released it too, again, this was an advantage of Bedrock. We just changed it to the latest model. Everything worked seamlessly. It was great. And then I would also say use prompt generators. We use the one from Anthropic they have. There's no, prompt generation is a dark art in science. But using an LLM to help here really did improve performance. It made it a lot easier here, particularly when you're not a dedicated prompt engineer and you're kind of a generalist. So a couple more things that we did to make performance better that were surprising to us. The data format really mattered here. We tested out YAML, we tested out JSON, we tested out XML. We actually found that XML performed the best, particularly in the context of comparison. We wanted to compare your performance last month, to this month. And actually the LM really struggled with comparison. And XML ended up being the best there by putting like a block of previous month and next month all into the report. In addition, we tried doing some of the math for the LLM, like 3 minus 2 is 1, your change was 1. That didn't help at all. It was actually just the XML format was the biggest improvement there. We were surprised by putting in the charts, the graphs. The LLM had all this data that generated those charts before in a numerical form, but actually putting the chart in really improved the quality of the output. That was at least surprising to us. And the last thing we did on a technical level was we separated the analysis from the summarization. So you could do this at least two ways. You go data into, and then you just have the LLM summarize it and generate about 150 word piece of text. Or you could go, LLM, here's the data. Give me your analysis of this data, kind of unconstrained. Now generate some awesome 150 word summary of this that's on brand and motivates golfers. And that was a much more successful path of attack for us than just going from A to B. Let's go back to that comment on other people's experience with AI. Giving users bad data, this might shock you all, not very good for users. And LLMs can be particularly prone to this without correction. And this initially was so bad we thought about actually killing the project because the data coming out was just really inconsistently accurate. That's me being polite. Again, LLMs are really struggling with comparison data between periods. And where we solved it, or how we solved it, was by having another prompt in a same model at the end, but different prompt in a different conversation, evaluate the text that was outputted, give it all the same data the first model saw, and say, essentially, more words than this, hey, is this right? And then put out some JSON output there that says, is accurate, true or false? And that went from, and if it's inaccurate, correct it, and provide new text. And that went from almost killing the project to, we don't even have a concern that this is going to be inaccurate anymore. It was a really meaningful thing. You may see some LLM judge, you might see this theme in other presentations. I've actually seen this LLM as a judge concept elsewhere. It worked for us. It's legitimate. It's pretty awesome. So that's summarization. Let's talk about some stuff I'm really excited about, but you don't hear about because it doesn't demo as well as some of the sexy Gen AI stuff. So let's go back to golf. As you all know as golfers, it is a sport of infinite complexity. There are over 38,000 courses throughout the globe, each with their own layout, each a unique snowflake, in 206 countries. Those courses have at least 544,000 holes on them. Each hole has multiple tee boxes. I did some rough math here. That's about 1.6 million tee boxes. And you got about 87 million golfers of all skill levels. And if you're an at-scale golf app, you have to handle all that. You have to handle the golf course in St. Helena Island, which I had to Google where that was, and it's in the middle of the ocean. But there's no excuse somebody's going to play there, and you have to make the app work there. And that's kind of a challenge that we've been addressing from the beginning of the app. And I'm excited about what we can do even more with LLMs there. So as you know, the objective of golf, this is a very basic thing, is to get the ball into the hole in as few strokes as possible. When you're doing golf analytics, the challenge is knowing where on earth that hole is on any given day. It moves, at some courses every day, every now and then in some courses, but it moves all the time. It's a moving target day to day. And if you do the analytics, it's a critical piece of getting it right for your golfer. So there's no single source of truth out there. There's not like a pin aggregating company out there. But there are pin sheets that some golf courses print out for their golfers that they give out of the first tee or you can get in the clubhouse. They're not a standard format. A bunch of different vendors make them. But what we were able to do is using an LLM, just a basic foundational model and a prompt, say, here's a picture of a pin sheet. Here's a little bit about the output you want. Give us back the data on how far from the bottom, how far from the left, and the green depth for this hole, so we can then take that data and then put the pin in the right location for the user. And it's an amazing piece of technology. I think this is a great piece of how we could use LLMs. And this actually would have been intractable but for LLMs. Sure, we could have spent hundreds of thousands of dollars on computer vision, writing our own algorithms, getting a data set. Literally no training, just took a picture of a pin sheet, worked on a prompt, and got data we wanted. you can say humans couldn't have solved this because the latency there between somebody taking a picture and somebody typing that data in would have been too long for somebody to just about tee off. And this is where I think there's a lot of value and a lot more exploration that could be done around LLMs. And I'm excited about what we're doing there. Hopefully there's some exciting things you all are doing there, either in any phase of this action-driving process, from capturing better data, analyzing that data better, and communicating it back to users. It's a pretty exciting space, and I hope you all are excited about it too. So thank you for coming out. Good luck out there. I would urge you to go hit up the golf simulator. You can compare yourself to a PGA Tour professional. If you're like me, you probably won't hit the green. Not the best golfer in the company, but it's a fun time. Thank you all for coming out. I don't think we have time for Q&A, but I would love to talk to you all, answer any questions if you want to geek out on golf data. I'll be over in the golf area over there for at least the next 30, 45 minutes if you all want to chat. So thank you all very, very much. Appreciate your time, and have a good rest of the conference.